in the FPD we have lived some things. That means we have forgot to discuss about some things. So let us discuss about that. So what we have forgot, that one is the normal. Okay, right, the normal first. I have told a little bit about the normal force. So how we will find the normal force? I have written that if this is untable, right? So if this is untable and one object is there which have some mass, then your weight will be to downward and your normal will be to upward. And the object, that means the mass m, will be able to sit. ये जो मास है ये टेबल के ऊपर बैठ सकता है. कब तक बैठ सकता है? जब तक weight equal to normal. Okay, so what is the formula of weight? Weight equal to mg. So when weight and normal will be balanced, then this mass can be sit on the table. But if the weight is greater than the normal force, then the table will break. Okay, so then the table will break. That means you will be fall down. So अगर जो weight है वो normal से ज़्यादा होगा तो आप गिर जाएंगे. So we have discussed about this in the weight structure. So what I have forgot, that is the direction of the normal. So remember, the direction of normal is always perpendicular to the surface on which mass m is situated, right? So what is the direction of the normal? The normal direction is always perpendicular to the surface on which it is situated, on which the mass m is situated, right? So if this is a table, if this is a wall, right? So if this is a wall and one mass is there, so the mass will be fall down, but we have given a force, right? That means if this is the wall and this is the blackboard, I will remove the knots. Then what will be happen? The board will be fall down. But I have given a force so that the board will be not fall down. So here the acceleration is 0, right? Because the particle is not moving to up or is not moving to down. That means we have given a force to the mass. So the mass is situated on the wall, right? If this is the wall, you take a massive object and if you will drop here, then it will be fall down, but you didn't drop it. If this is the wall, you take a mass and give it some force to the wall, like so. Your force is towards the wall, then the mass will be in tight place. That means एक massive object ले जाइए और उसको wall की तरफ force देके उसको वहाँ पर रखिए, ठीक है? So the mass is situated on the wall in a hanging state, but you have didn't give any support. You have given a force into the wall. You have given a force into the wall through the mass. So what will be happen? So your weight will be downward. Okay, so your weight will be downward and it is not sliding, right? So the normal force is towards the force. So you have given a force to the mass, but the normal force is perpendicular to the surface. So this is the okay. So the normal is outward to the surface. That means the normal is perpendicular to the surface. So the mass is stopped by giving some external force. So what will happen? That means your normal is to perpendicular to the surface on which it is situated. So remember the two cases. That here the object is standing, that means the object is situated on a table in horizontal, but here the object is in vertical. That means this is the wall. Okay, so the wall is not in horizontal, the wall is in vertical. If you will drop it without giving, if your F is 0, then the mass will fall down, but we have given some force to press the object. So here in this case your F will be equal to N, right? So your acceleration is 0. So it does not depend upon the weight, but it depends upon the force. So your F will be N, right? But remember another thing. Here the weight and there is friction also, right? In this surface, if you will leave the force, then it will move to downward. So this is your frictional force. So we have discussed about frictional force also. So your W equal to mu N. So these are the FBD, right? Your force is equal to normal and your friction is equal to mu N. So remember these things. So These are the two important things of the normal force about. So remember, the normal force direction is always opposite to the surface. So let's discuss about motion activity. So next is your frictional force, right? So yeah, I have lived it. That means I forgot to tell you something about the frictional force. So what are the external of the frictional force? That means what is the expression? F is equal to mu1, right? So this is the magnitude of your frictional force. That is your expression of the frictional force. And remember, your frictional force, that may be your opposite to the normal or anything, but the frictional force is the direction is opposite to the acceleration. So this is opposite to motion, right? On which direction it is moving, in the opposite direction your frictional force will be act. So if you want to know more about the frictional force, then go to the previous lectures. So what are the, that means, so one important thing, that means the types of the frictional force. Types of frictional force. So remember the three cases. One case is that there is a table and an object is there, and the object is pulled by another object, right? So this is M1 and this is M2. So if M2 is greater than M1, if M2 is greater than M1, what will happen? So the motion will get started and the particle will move to downward. So this is the acceleration. So the particle will move to downward. If this is moved to downward, then this one will also move to your left side, right? So M1 will move to in this direction and M2 will move to downward. But remember, there also acts some frictional force in this direction. So such type of frictional force is called static friction. What is called? Static friction. Static friction. Okay, so this is called static friction. Static, S-T-A-T-I-C, then friction. Then the second case is that we have two objects. Okay, right. One object is moving to in this direction with v1 velocity. Then another object also moving to in this direction with v2 velocity. So what happens when there will be collision? That means the surface will give in to one frictional force, so that the object will be rest. That means if two bodies are moving, when they are collide to each other, then the velocity will also to decrease. So what will be happen? So when in the moving case, so there will be frictional, so that we call as kinetic friction. Kinetic friction. That means the friction in the motion state, that we call as kinetic friction. So this is the static friction, that is the table. And we have static means in the rest state. So the M1 is rested, but the M2, if given some force to M2, then the M2 will move to downward and it will pull the M1, so that the M1 will move to the left side. So that will be one frictional force opposite to the direction of motion, that is called as static friction. That means it is initially in the rest state, but when M2 will provide any force, thus that will pull to the M1 into the left side. So there will be one friction in the opposite to the direction of the motion, and that called your static friction. But in kinetic friction, two bodies should be moved to each other, right? The two bodies are in motion. Remember, here one object in motion, here two objects are in motion. So their friction is called as kinetic friction. That means it will give an friction to M1, M2, and M2 also gives some friction to M1, right? So this is kinetic friction. And another friction is so this is an inclined plane, right? So this is an inclined plane. So no force is given to the mass, but the mass will get motion to this direction, right? It will be sliding friction, or your rotation friction, or your sliding friction. So that we call as your okay, you can call it as sliding friction or rotational friction. So your frictional force will be in the opposite direction. to the motion. So look to the three topic. That means the three category. So we have some. So we have three categories. One is your static friction, another is your kinetic friction, and this is called as rolling friction. Rolling. Right. So we have three friction. One is your static friction, another is your kinetic friction, and another is the rolling friction. So try to understand. Here is one object is moving, another is rest, and it is pulling to M1. In the second case, both objects are moving, so it will give one friction to this, and this one also give one friction to this. So this is called kinetic friction. And in the rolling friction, there is an inclined plane. We didn't give any force to the M1 to the M object, but still it will be moved to the downward. So when it will be moved to downward, one force will oppose it to the motion, that called the frictional force, and such type of friction is called rolling friction. So an object is placed in an inclined surface, so it will try to move to downward, but an opposite force will oppose it to move downward. So ये डाउनवर्ड आने के लिए चाहेगा, लेकिन उसके अपोजिट में एक फोर्स है जो उसको रोकेगा डाउनवर्ड जाने के लिए. उस टाइप ऑफ फ्रिक्शन को हम कहते हैं रोलिंग फ्रिक्शनल फोर्स. And if two bodies are moving to each other, then one body will give to another. One body will provide to another and frictional force, and this one also provide an frictional force. So such type of frictional force is called kinetic frictional force, and that is the static frictional force. Okay. So all expression are same, but the mu here different. So your mu is the static friction, that is mu s, and in the kinetic friction, this is mu k, and this is your rolling friction, so that will be mu 1. So what is mu? This is the coefficient of friction. So these are the three types of friction. So what is the coefficient of friction? So this is the mu s. Remember, mu s is greater than your mu kinetic friction, and this is less than rolling friction. Okay, right. So try to remember. These are the coefficient of friction. Coefficient of friction. So try to remember that your static coefficient of friction is greater than kinetic coefficient of friction, and is greater than rolling coefficient of friction. So there are three types of friction. One is static, kinetic, rolling, and the coefficient of frictions. So that are so static coefficient friction is greater than. So what is the frictional force? F equal to mu L. So this is the vector quantity. So it is depend upon the coefficient of friction and then your normal. Then what is the angle of friction? So what is the angle of friction? Remember, this is an object. So if it is moving to in this direction, that will be your frictional force, and that is your normal. Okay. So remember, tan theta okay, we will take the angle of friction, that will be represented by lambda. So lambda is your angle of friction, right? So okay, remove this and we will start from angle of friction. Okay, so next we will look to the angle of friction. So remember the formula. What is the angle of friction? So angle of friction we can represent it by as lambda. So lambda is your tan inverse mu. Remember, so the coefficient of friction will be given to you. Then what is the angle of friction? So this is an angle. Okay, so the formula is lambda equal to tan inverse mu. So these are all three types of friction, then frictional force, then this is your angle of friction. So this is more about your FBD that we have forgot to study. Okay, so let's discuss about those 2-3 problems about your FBD. So what are the problems that we have to discuss? The application of FBD. So we'll study the application. So what is the application of FBD? One case we will discuss lifting of mass. Lifting of mass, and the second case we will discuss about your Arthur machine. So lifting of mass and your Arthur machine. Okay, so these are the two applications of the free body diagram. One is your lifting of mass, another is the Arthur machine. Let's first discuss about the lifting of mass. So what is the lifting of mass? So we have a bucket and one pulley is there. So this is the pulley. Which one is the pulley? This one is the pulley, and this one is the string. Okay, so the object has some mass. That means M is the mass of the object, and this one is the object. So this is the object, and M is your mass of object, right? So this is the mass of object, and that will be your weight force. There will be no normal force or no frictional force, because no surface is there. If surface is there, then will be normal force, because normal force is perpendicular to the surface. And since surface is not there, so normal force is not there, so frictional force also not be there. So remove about the normal friction, and that is 2 or 3 force we have discussed in the FBD. One is your weight force, so that will be moving to downward, and another is the tension force. So this is the tension force, right? And one force is given by you. That means look to the system. So you have an object, and the object is connected to a string, and the string was pulled by you. The string was pulled by you by an force. So हम एक फोर्स दे रहे हैं उस स्ट्रिंग को जो बकेट को उठा रहा है पानी के साथ, ठीक है. So this is an perfect example of your well, old well, that old model well. We have one pulley and one bucket, and we are taking the water with the help of the bucket by giving some force to the string. That means we are giving some force to the string. So that force is your F. So this force is given by you. Okay. So the F is force given by you to the string. Okay. So F जो force है वो string को हम दे रहे हैं. So F equal to T. So what is the FBD says here? What is the FBD say? So this object is moving to upward, right? So these are the theory part. That is, the force is given by you to the string. Then M is the mass of the object. Then what's happening? So what will be your acceleration? So W equal to mg. And remember one more thing, that the object is moving to upward. So this is the acceleration, right? This is the acceleration. So another force will be there, that is your pseudo force. Because when acceleration is there, pseudo force is there, and the pseudo force is opposite to the acceleration. So what is the FBD? T is towards the string, right? We are giving force to the string now. So string is towards the string. So here also tension. There is same string. This string is connected to here. That means this is your hand. Okay, so this is your one hand, and this is the tension connected to your pocket. So the structure is like that. You have some mass M, and the mass is moving to upward. So this is the direction of acceleration, and one tension force is there that is connected to the string, and one pseudo force is there. So pseudo force is there, weight is there. So what is the FBD? So T equal to, this is a W plus pseudo force. So what is the weight force? This is mg, and what is the pseudo force? That is ma. So T equal to m into g plus a, right? So what is g? G is acceleration due to gravity, that value 9.8 meter per second square. So your T equal to m into g plus a, right? Again, so this is the first case. Look to the second case. What happening here? Here is one string is there and you have given some force and string force is opposite. So T equal to F. So what is your F? F equal to m into g plus a, right? So F equal to m into g plus a. So remember how much force we will have to give. So F equal to mg plus ma, that means, so the force that will be given by you. So what is m? M is mass of the object, g is acceleration due to gravity, and a is the acceleration with which the bucket will move to upward. So how much force will be given to you? So you have to give m into g plus a force, then the bucket will move to upward. So this is the physical things of your FBD, lifting of mass. Remember here one string is there, so here tension, that will be same because the string are same. We will discuss later, that is in the problem section. If a two string will be there, then what will be happen. So this is your lifting of mass. Then we will go to the Attwood machine. So what is the Attwood machine? We have a pulley, same case here. This is an support, okay? So this is an support, and one mass is connected to here, M1, and another mass is connected to here, that is M2, right? So one mass is connected here and M1 mass, and M2 mass is connected to the next, and the string is same, so the tension force is same in both cases. Okay, so that will be your W1 and that will be your W2, right? So remember, if leaving the lifting case, if your M2 is greater than M1, so this is the case one. If M2 is greater than M1, so what will be happen? M2 will move to downward. M2 will pull M1. So M1 क्या करेगा? M2 को उसकी तरफ खींचेगा. So यहाँ पर एक्सेलरेशन का डायरेक्शन कहाँ होगा? डाउनवर्ड. और इसका एक्सेलरेशन कहाँ होगा? upward. So try to understand. Your M2 is greater than M1, right? Your M2 is greater than M1. We didn't give any force, right? We didn't give any force to M2 or M1. Just we take the case that your M2 is greater than M1. Okay, so what will be happen? Now M2 will move to downward. So M2 जितना वेलोसिटी से भागेगा और जितना एक्सेलरेशन से भागेगा, M1 भी उतना एक्सेलरेशन से भागेगा, बिकॉज ये एक स्ट्रिंग के साथ कनेक्टेड है. M2 is connected to a string M1. So what will be the acceleration of M2? That will also be the acceleration of M1. So M2 और M1 इन दोनों का एक्सेलरेशन सेम होगा, लेकिन डायरेक्शन जो है वो अलग होगा. So M2 direction is to downward and M1 direction is to upward. Because why? Because M2 will pull M1. Since M2 is greater than M1, ये इसका मास जो है वो ज़्यादा है M2 से, so ये नीचे जाएगा, ये ऊपर जाएगा, ठीक है. So acceleration same होगा. Okay, since acceleration is there, so there will be pseudo force. And here also same case, it is moving to downward, so your pseudo force will be upward. Right. So now we'll look to the FBD. So what happened in first case? That first case means to the mass M1. What will be happen to mass M1? So your mass M1 will be T equal to W1 plus Fp. Right. So T equal to W1 plus Fp. That means T equal to M1g plus M1a. Then what will be happen to mass M2? The mass M2 will be T plus, what will happen to M2? T plus Fp will be W2. Right, so these are the FBD of the two structure. So M1 will be given to you, and you know the G value, so you can calculate the W1 value. Then Okay, so m1 m2 will be given to you, and t will not given to you. m1 m2 will be given to you, and you know the g value, that is 9.8 meter per second square, or similar to 10, right? So you can solve these two now. So this is the first case and the second case. So you can subtract these two also. What is your FP actually? So from this we can get that t plus m2a equal to m2g. So this is one equation, and this is another equation. So you solve these two equations, you will get the acceleration. Actually the question here is find out the acceleration. m1 will be given to you, m2 will be given to you, then find out the acceleration. So you just subtract these two, you will get the acceleration, right? So this is all about your Arthur machine. So if you will solve these two equations, you will get your acceleration as, what will be acceleration? Just subtract equation 1 with equation 2, you will get the acceleration. So that means your acceleration will be, okay, to substitute your t1 value, okay, I am writing here. What will be the acceleration? You substitute t from this one, this is one equation, and this is the second equation. So substitute 1 in 2. Substitute 1 in 2. So what will get? Substitute 1. So that will be m1g plus, m1g plus m1a, that is equal to t. m1g plus m1a, that is equal to t. And here t equal to m2g minus m2a, right? m2g minus m2. So what we get? Now we get m1 plus m2 into acceleration equal to m2 minus m1 into g, right? So your acceleration will be m2 minus m1 divided by m1 plus m2 into g. So this is your acceleration of a Arthur machine. So we have studied two applications of FPD today. That is your lifting of mass, that is lifting of object, and this is the Arthur machine. So this is important. Okay, write the FPD, then you solve, then you will get the answer. Okay, in the Arthur machine, also one question will be asked to you. So again, so this is the Arthur machine. We have a M1 and we have a M2, and this is a pulley. We have some support. So we have find the acceleration as M1 minus M2. M2 minus M1 divided by M1 plus M2 into G. Okay, so we got this acceleration value, right? So here what happened? So we have a T equal to M1G plus M1A, right? So we have T equal to M1G plus M1A. So one question is that this is one also T, then this is one also T. So we have got this A equal to M2 minus M1 divided by M1 plus M2 into G. And this is the equation that we have got before 5 minutes, that T will be upward and the mass is since there, that will be a weight force, and since it is moving to upward, then that will be pseudo force, right? So T equal to M1G plus M1A. So you can substitute the acceleration here, then you can get the T value. Then what is the question here? That the question is that how much force will be act to the pulley. That means what will be the pulley force. So the pulley force will be, remember, that is the pulley force, that will be 2T. Okay, because one T is acting due to M1 and another T is acting due to M2. So how much force will act to the pulley? मतलब pulley के ऊपर कितना force गिरेगा? So that pulley equal to 2T. So how we will find T? T equal to M1G plus M1A. So substitute this acceleration here and solve this, you will get 2T. So what is the pulley force? That will be equal to 2T. And if you will find this, that will give you 4 M1 M2 divided by M1 plus M2 into G. Okay, so this is the pulley force. So this is the attitude machine now completed. We have attitude machine. So this is the acceleration we have got. Then substitute this acceleration here, you will get the tension, right? And what is the pulley force? Pulley force is equal to 2T. Just to multiply 2, you will get this. Okay, so here we will start the PPT. Okay, so let's discuss about one little thing, that is your impulse. What is impulse? So the impulse also, it can be denoted by your I. It can also denoted by your G. So these are the symbol of impulse used, but we will use I for the impulse. Okay, so what is impulse? So remember, so what is the impulse? Impulse equal to force into small time. Okay, so impulse equal to force into small time. So remember, so di equal to F vector into dt. So this is your impulse. This is small impulse, right? If you integrate impulse, that will be give you integration of di. So this is nothing but integration of f dt. So this is T1 to T2. So this is the impulse, right? So okay, you can write it as a delta t also. So delta t is nothing but the small time. So this is okay, remove the bracket. So this is the impulse, that is force into small time, f into delta t. Delta t is a single word, that is delta t is your t2 minus t1. So because okay, so this is the small impulse. So what is the impulse? Total impulse. So this is the total impulse. So your total impulse is nothing but integration of di, that is the di is your f delta t. When we are using integration, we will write a dt. Okay, right? So here delta t is small time, so we have written this. So impulse is equal to force into small time. And another expression, what is the another expression? Remember, we have f equal to dp by dt, right? So this is the Newton's second law. So what is the Newton's second law? The rate of change of momentum equal to force. So you can write here that this is Newton's second law. Okay, write here Newton's second law. So this is the second law. So what will be dp? So dp equal to f into dt, right? So dp is also equal to impulse. Remember, so dp is also equal to impulse. So this is another expression of impulse, that is the dp equal to impulse. So what will be your impulse? Remember, impulse equal to integration of, that is ft, and that also can call as, this is the integration of a dp also, p1 to p2. So that will be give you p2 minus p1. Okay, so this is also another expression for impulse. So what is the impulse? This is the integration of f dt and the integration limit at t1 to t2. But f dt also called as a dp, right? So we can write dp also. When we write dp, the time limit will be changed to p1, p2, and p is the momentum, right? So p is the momentum. What is p? So p is the momentum. So sometimes we call the change in momentum also equal to impulse, right? So impulse also equal to change in momentum. Change in momentum, because there is the change, p2 minus p1 is the change. So this is all about your impulse. So remember, so force into small time, or impulse can call as change in momentum. So this is the expression for impulse. If you like it, please share and subscribe and click the bell icon for new videos, so that it will be helpful for others also. Okay, thank you. Jai Jagannath.